Okay, let's continue. For fx to have an asymptote at y equals 2, so, oh, they're saying to have, I don't think they're saying that the asymptote, I think the asymptote is a horizontal asymptote. So I think we want to say that the limit as x goes to infinity of px over qx equals 2. So I guess we could just say the limit as x goes to infinity of px equals twice the limit as x goes to infinity of qx. I guess that's what they want here. 306, 307. For them to have an asymptote at 0, then the polynomials p must have what relationship? So that q of 0 equals 0 and p of 0 does not equal 0. Okay, 308. If after it has asymptotes at 3 and 1, then fx has what asymptotes? Oh, that's interesting. That's interesting. So we could have something like f dash x equal to x minus 1 and 3x. Interesting. And then, but we need the original function that has this as a derivative. So let's see if we can work it backwards. So um, let's make it a square. Okay. So that it looks more like the reverse of the quotient rule. So it would be, it was originally the bottom, and then the bottom times derivative of the top minus the top times derivative of the bottom. So this must have been, hang on, x minus 1. So the bottom, okay, so I need to get a total of 3x. So maybe that could have been like 2. Could we have a 2 and a 2? No. A 3 and a 3. The bottom times the top minus the top. Okay, the top would have to be something like 3x. No. I need something where a derivative of 3 but cancels the minus 1 here. 3x. No, that's not going to work. It's not going to work. Okay. Oh, actually, because the square here, I just realized this needs to be a square. So that might help me out a bit. So that's the bottom squared. The bottom times the derivative of the top minus the top times the derivative of the bottom, which is going to be 1. So let's see what happens if I have an x squared. So the bottom times the derivative of the top minus, okay, what about minus? So that'd be minus 2x and then minus x squared. So so if I change this now to 1 minus x, Oh, no, that's not going to work. Okay, maybe it's a bit tricky to kind of construct it in reverse. Maybe I should just think about the graph and its slopes. So if we think about it like this, so we have a graph that has an asymptote at 1, and then also at 3. So it could be something like that. So I think it still has the asymptote at 1, but then has an asymptote of 0 then. So I think we still have the 1, but then it'll be a there. No. It's 3. Slope is 3. I'm not sure actually. I do actually want to reconstruct it if I can. Let's see if I can. Okay, so the function would be, I'm going to say definitely an x minus 1 here. And then I'm not sure what to put on the top, but we'll just say ax plus b. So then the derivative would be the bottom squared, the bottom times the derivative of the top minus the top times the derivative of the bottom. So that would be ax minus a minus 2a minus b over x minus 1 squared. So we need the a definitely has to equal 3. No. Because of the square now. Maybe I should make this ax squared. Yeah. So the bottom times the derivative of the top, which would be 2ax. Yeah, okay. Let's see if this works or if I need to add in more. The bottom squared, the bottom times the derivative of the top plus the top times the derivative of the bottom, x minus 1 squared. So on the top, that's 2ax squared. Oh, plus another a. So that's 3ax squared. 2ax squared plus another ax squared minus 2ax plus b. Actually, that works. We could just say a is 1 and b is 0. So this would equal then 3x squared minus 2x all over x minus 1 squared. So when x tends to infinity, you get the horizontal 3 and you have the vertical 1 here. So the original function is simply x squared over x minus 1. So this has the asymptote x equals 1 and y in my case equal to, well, it's infinity, so there isn't one. But I feel like there's probably lots of flexibility here, but it should still have this asymptote at x equals 1. But I feel like I could have manipulated to have different vertical asymptotes. Possibly. Maybe. I'm not sure. Okay. Okay. And then that's 308. 309. Both these functions have asymptotes at x is 1 and y 0. What is the most obvious difference between these functions? Well, I mean, this one is symmetric, so that the asymptote is a line of symmetry for G, but not F. True or false? Every ratio of polynomials has a vertical asymptote. That's false. So like, just take the example, x squared plus x squared minus 1 over x squared plus 1. Actually, let's make it simpler. No vertical asymptote there. Let's check the answers that we can. 310. Okay. Right, 306 no, but we can have 307. The degree of Q must be greater than the degree of P. The degree of Q must be greater than the degree of P? Oh, so it's not an asymptote at x equals 0. They meant an asymptote of x equals 0. A horizontal line. Yeah, and in that case, that would be right then. Okay, so I better tell them that that's a typo. Degree of Q is greater than that of P. So that means then they must have meant here to have an asymptote of y equals 2. So that should have said then of y equals 2. So that would mean Q of 2 equals 0 and P of 2 is not equal 0. Oh, well, actually, it doesn't have to be at 2. Sorry. No, it does. Y equals 2. Oh, no, that's the horizontal one, isn't it? Y equals 2. So I think I was right with actually what I said. Yeah. But I should say of, to have an asymptote of x, no, x, y equals 2. No, that's the vertical line. No. Hang on, I'm mixing up my x and y's. It's embarrassing. Okay. So this is an asymptote at x equals 0. So what they mean is, I think they meant to say of y equals 0. I think that's what they meant. For it to match the answer at the back, the degree of Q has to be greater than the degree of P. So for this one to have an asymptote at y equals 2 is a horizontal line. I think they must maybe mean of y equals 2, but there's no answer at the back, so I can't know. Yeah, okay, I think that one should say of y equals 0. Okay, yeah. 309. Oh yeah, I forgot to put in the... Oh, well, yeah, okay, that's a possible difference about the left and right limits, yeah. Yeah, what I meant by the symmetry is in the first one, you get kind of a split like this, but in the second one, it's symmetric because of the square. And that's it, 310. Okay, so I'll just open up a ticket about 307. I feel like that's a typo. Okay, and then we have applied optimization next. There's all the word-based practical problems that I enjoy. All right, let's wrap it up there.